Add a member variable to the graph class in the right column of this page to hold a collection of vertex objects. Also, add a member variable to hold a collection of edge objects. Okay, let's go over here to the graph class. Here's what that'll look like. You will say array list, and if you pick linked list or tree map or whatever your favorite collection is, that's fine with me, I don't care. But we did a lot of stuff just like this in your assignments, so I really do expect you to have been able to handle this problem. What shall we call it? How about vertices? Sound good? And array list of vertex, edges. Okay. So there's the answer to number 2. Any questions? Great. Number 3, add a constructor to the graph class and initialize those member variables that we just made. So it would probably, constructor always has the same name as the class, right? If you didn't know that, how did you do your assignments, right? I mean, you really better have known that. If not, I'm going to be looking really closely at your work, just letting you know that. Now, in the constructor, initialize these things. So how about vertices equals new array list of vertex. Now, obviously, I didn't give you enough space to do this assignment. I'm sorry about that. Basically, I suffered for it because I had to read everything that was crammed into the margins. And let's see, how can I make this cleaner? I'm just going to untabulate just because it makes it a lot easier to read. We're okay with that? This should be tabbed over a little bit. And now I'll say edges equals new array list edge semicolon. Okay. There you go. I made a constructor and I initialized those variables. Now, a lot of people added all kinds of weird stuff to your graph class, extra member variables that you didn't need and things like that. That's something I've kind of been jumping up and down about, is don't do that. Add just the things you actually need. And these are the things you actually need. So you did lose a few points if you started adding extra stuff, or if you didn't realize that you needed to put the type in the generics field for the class, or if you didn't know how to call a constructor. That's worthy of losing points in my opinion. If you forgot the parentheses or the semicolon, I don't care, because if you were to do that and you compile, the compiler would yell at you and then you'd say, oh gosh, I forgot, and you'd go fix it, right? So that's not the kind of thing I'm testing. The kind of thing I'm testing is, do you know how to initialize a variable? You know, use an equal sign, call new, things like that. All right. Number 4, add a method to the graph class with this signature. Okay, I'll just copy that. Implement this method to add a new vertex. Okay, so there's my method. And now let's implement it. What does implement mean, by the way? How does implement differ from declare, differ from instantiate? Anybody want to call that? Yeah, so to declare something is to say, here's the type and here's the name of it. Declare really means push something onto the stack, or this is a declaration of a method, in this case a constructor. To declare something is to say, this is the way it is. To instantiate means to call new. It means to make an instance of something on the heap. To implement means to provide the details. In this case, it's the body of the function. So I am now implementing this method. Okay. Add vertex, int y. So I have this vertex class, and it takes an x and a y. There's lots of ways I could actually do this. I could come up here and add a constructor to the vertex class. That's what most of you did. If I didn't want to, I could do it like this. Let's do it a few ways. Vertex v equals new vertex. And I could say v.x equals x, v.y equals y. I should put those in separate lines, whatevs. And then I could say vertices dot add v. That's one way to do it. Let's do it another way. How about let's pass x and y to the vertex constructor. Now, does the default vertex constructor take 2 parameters? Certainly not, because how would the compiler know to do that? So you can't use the default constructor, you have to add one if you do that. Now, why am I calling it xx and yy instead of just x and y? I don't want a shadow because it's bad practice. Now, if you did shadow, that's okay as long as you didn't do this. If you wrote that, obviously the compiler is not going to magically know what you mean. But if you wrote like that, like this, then the compiler does know what you meant. So this is valid code. This is not valid code. This is valid code. And however you wrote it, I don't care as long as it works. There we go. We did the next one. What number are we on? Did 4, let's do 5. Add a method named addEdge. Notice now I'm not providing you any details. I'm just trying to test, okay, now can you know what's going on? And given that you just did one, you should kind of know how to do this now, I think. I just said add a method named addEdge and basically make it work. So there were lots of options on this question. I'm running out low on space, but void addEdge. The one that actually kind of made me laugh because I didn't think about it before I wrote the test, but this is perfectly valid, is a lot of you assumed, let's assume you already have an edge that's completely allocated and is already there and does what you want. So you're just going to pass in an edge. And they just said edges.add e. There you go. That meets the requirements of the assignment, so if you did that, you should have got full credit. What I was actually thinking is, let's make a function that's a little more bit convenient and does everything a user would want to do in order to add an edge. So I'm going to go down to the next page so I have more room. I was thinking, let's do something like this. How about we pass in a int x1, int y1, int x2, int y2. See how that's a more useful method because it doesn't require the user to have an edge ready to go, which is a very unlikely situation. So I was kind of hoping you would do something like vertex v1 equals new vertex. Oh, in fact, let's just use the method we just wrote. How about that? Let's say vertex v1 equals add vertex x1, y1. How about vertex v2 equals add vertex x2, y2. And then edge e equals new edge v1, v2. And then edges.add e. Something like that. This would be an actually useful way to add an edge to a graph and doesn't make a whole lot of assumptions. Although, notice how it depends on this add vertex method returning something, and I think I actually made that thing void. Well, you probably didn't do this. In fact, I don't think anybody did. But if I were writing good code, I'd probably do something like that. Because the caller is free to ignore the return value, but it's kind of useful to actually return the vertex you just added in case you want to use it, say, to make an edge, right? So that's what I was hoping for. Nobody actually did that, but that's okay. A lot of you got this one right. Any questions on how to add an edge? Or, now the one thing a lot of people did that wasn't quite right is you passed in an x and a y, and then you added an edge. What's wrong with that? Yeah, how do you make an edge between just one point? I guess you could have an edge to the same point, but nobody actually made an edge to the same point, so yeah.
What if you passed in like vertex A and vertex B?
That's another perfectly valid thing to do. So yeah, if you assume we have vertex A and B, pass them in as parameters, and then add an edge that connects those two vertices, that would be great. Let's do that. Vertex A, vertex B, A, B, doo, doo, doo. This would be a correct answer. Now, by the way, I'm saying all these things are correct and incorrect. If you look at your test and that's not how it was graded, you know, feel free to come to me and say, hey, technicality, that type of a thing. I really do want to face all the technicalities with you that you've got. If you have questions more along the lines of, hey, I think you were just really mean to me, then I'm going to push back a little because I tried really hard to be consistent with everybody. And so it's not very nice for me to just give whiner points. Does that make sense? Because then it's not nice to the people that don't whine. So, and I don't mean to say it's whining. There are valid cases where maybe I didn't understand you. So if you think I looked at your assignment and misunderstood and graded it unfairly, you absolutely should bring it to me, and I don't consider that bad or whining or anything like that. So your call. If you feel you need to bring something to me, please show me and ask about it. But I will push back if you're just wanting better scores because you need it really bad or something like that. Sound reasonable? Yes?
Did you assume for that the vertices have already been added to the vertices already?
Ah, excellent question. So that is what would be called an assumption, and it's really important that programmers understand the assumptions of the APIs. And this is the kind of thing that would have to be documented in the API documentation, or if you're writing your own code, add a comment here that says, this method assumes A and B are already in the vertex list, or something like that. I guess I didn't ever teach that explicitly. I am teaching it to you now. Because I didn't, I went with whatever you did on your test. So if you made assumptions like that, cool, I didn't take off any points. I don't think. But that would be a serious bug. If you wrote a function and didn't document what assumptions it behaved on, that would be setting up whoever used your method for disaster, right? Therefore, either do what's obvious or be really explicit in documenting how your method behaves, otherwise disaster will occur. You ever seen Phantom of the Opera? There's this ridiculous line where he says, if these demands are not met, a disaster beyond imagination will occur. And then the chandelier falls on somebody and kills somebody. I just, I mean, that's terrible. I don't mean to belittle the value of life, but my imagination's just a little bit stronger than that. I was imagining, earthquakes and the whole place falling down and, hordes of zombies rising up and... Okay, moving on. Awesome music, though, by the way. Great play. Silly story, but good play. Okay. Add edge. Add a method named edgeCount that returns the number of edges in the graph. Also, check to make sure the number of edges is not less than the number of vertices. This is a silly requirement, but I said to do it, so you had to do it because that was the test. So, edge count. Void edge count. It should take no parameters. Some people did this. Wait, it shouldn't be void. It should return an int. Okay, a lot of people had you pass in the edge count. What's the point of calling edge count if you have to know the edge count in order to call the edge count? I mean, that's just... I don't see the point, so I didn't like that. But this is the signature I was going for. It's not that hard. A lot of people wrote for loops to run through and count up the edges. I guess that's technically valid, but here's what I was hoping you'd do. Edges.size. Bam, done. Moving on to the next question. Except I said throw an exception. Okay. If edges.size is less than vertices.size, then throw new runtime exception. Oh noes. Badness has occurred. A disaster beyond imagination has occurred. Okay, here's the one that I thought was the most hilarious. Informative. Okay, that cracked me up. Oh no, they actually made an informative exception here, which assumes that I had made a class that inherits from the exception class, which by the way you can do in Java, and you can throw an informative exception, which presumably inherits from runtime exception. There you go. So we did edge count. Oh, by the way, if you did this, if you first return the size of the edges, then you check to see if it's out of range, you are following instructions to a stupid degree. No offense, I don't mean to call anybody stupid, but you did something stupid. Obviously, you can't return first and then check later, right? This would be unreachable code. Just pointing it out. Yes, I did actually word it in that order maliciously because I'm a conniving professor, but don't let anybody hold your hand like that. You do have to think a little bit in this class. Okay. I'm not that angry. If you did that, that's okay. It's a normal mistake. But you do have to say return after you check for exceptions. All right.